And hello, everyone, and welcome to the March Livestream Q&A. Let's do a quick check-in with the chat room. And if you're online and watching this, jump on the chat room and tell me how you can hear me, if the audio and video is good, so we can get started with this March Livestream Q&A. I've got so many questions from everyone. Very excited to get started. Just want to get some feedback from you. And let's see. All good. All good. Woo! Fantastic. Cutting through the noise. Kevin asks, do you have any advice about cutting through the noise to achieve a bird's eye view of the blockchain technology space as a whole? I spend every minute of my free time learning about new projects, new technologies, protocol improvements, consensus mechanisms, and I can barely keep up with a fraction of it all. As someone who spends much more time learning in this space than I do, how do you filter through it all? Do you recommend any sources in particular that do a great job at distilling the highlights of what's going on right now? Kevin, that's a great question. And I know that for many people, I serve as that source. It's very difficult not only to keep up with the extremely rapid pace of change in our industry and our space, but also to discern what is real and what is not. And, it's not simply a matter of the truth falling somewhere on a random curve or the news sources being randomly distributed. There are people out there who are actively trying to sell you something. And there's a lot of money floating around in this space, which has attracted a lot of unscrupulous people. So it's not just about keeping up. It's also about getting sources of information that are neutral, that don't have an agenda, or if they do have an agenda, it's an agenda based on some kind of principle and not an agenda simply based on personal enrichment and promotion, right? So this is a big problem. There aren't that many neutral voices. Most people are trying to sell you something. And of course, there's a lot of companies that have now joined, both companies within our space like startups, but also companies from outside the space, traditional industries like financial companies, insurance companies, banks, etc. And they're all trying to push their own agenda. They're all trying to tell you, for example, that we can continue to do business as usual with blockchain, and we don't really need any of this open, borderless, decentralized cryptocurrency shit. We can just do databases, and that's just as good. All we need to do is give complete power to the banks. So there's all of these challenges. To me, the best approach for cutting through the noise is to go directly to the technology and to go to the source information. So I look at code, and I use the code and try to understand what it does. In addition to that, I read the developer mailing lists. I read the discussions on GitHub. I read the pull requests. I read various chat rooms. And not all of them are good anymore. A lot of the very qualified developers have left many of the public chat rooms because of all of the noise that's happening there. And in order to get work done, they've gone to more private forums. But you can still find a lot of good information online. So to me, the focus is always on the technology. If you go back to the technology and read about what the developers are doing and also read what the code is doing, then you can get a direct perspective of what's actually happening in the space rather than the marketing brochure or the agenda-driven series of talking points. Adam asks, unknown block versions are being mined. It's possible unknown rules are in effect. When I run my Bitcoin Core node, I see this message, warning, unknown block versions being mined. It's possible unknown rules are in effect. I've read a tweet by Luke Dasher that this is a result of miners violating the Bitcoin protocol, typically in their overt usage of the ASICBoost exploit. What does that mean, and should I be concerned? Really, no, you shouldn't be concerned. What this means is that miners are using the block version field within the block header in order to create more possible permutations of the block hash. And the most likely use for that is in order to take advantage of ASICBoost. There are a couple of different ways to take advantage of ASICBoost. And ASICBoost is basically a shortcut in the SHA-256 algorithm that allows for mining at a maybe up to 20% less energy use for the same number of hashes. And so ASICBoost is being used by a lot of miners in order to reduce their energy cost. It's an advantage. It's a competitive advantage. It can significantly affect the bottom line, the profitability of a miner. And so ASICBoost is being used. And when ASICBoost is being used, because of the particular structure of the block header and the way this shortcut in SHA-256 works, they need to change some bits in some part of the header in order to take advantage of ASICBoost. And given that there are not necessarily that many places where you can make changes in the block header without it affecting the outcome, they'll use the block version. And your Bitcoin node will complain about this because Bitcoin nodes are using the block version to try to figure out if the consensus rules have changed. And this is from a time when the block version was used to signal various votes in the Bitcoin system, for example, for the adoption of various soft fork features or even hard fork features. So typically, your node simply ignores that. The warning you're getting is just to tell you that it's seeing a block version that seems to be saying something about the block, but it doesn't know what that means. And what it's seeing really is junk. It's seeing random bit changes in the block version, which don't actually mean new rules are in effect. It just means that ASICBoost is in use. You don't need to be concerned. You can ignore that message completely. Hi, everyone. I see lots of people joining from all over the world. Thank you so much for joining this March live stream Q&A. It's great to be answering your questions. And as always, thank you so much for all of your support on Patreon. It's made it possible for me to do more work in more countries and visit more places and do more videos in more languages and get slightly better equipment. Today, for example, I'm trying out some new lights. I've never had lights before, or rather, when I have had lights before, these lights have simply been a collection of every lamp, uplighter, side table lamp that I can find in whichever Airbnb or hotel I'm staying, all arranged around me. And I actually have some real professional LED lights. So it's no longer dark and gloomy in here, and you're getting the full HD experience. That's just some of the equipment. I got some better microphones as well. Hopefully you can hear higher quality and better cameras. So things are getting a lot better, and thank you so much for all of your support. Next question comes from Moho. Linking BIP39 mnemonic seed and addresses. Moho asks, I tried to recover a wallet with my BIP39 mnemonic seed, but the balance of the wallet is showing 0. I'm quite annoyed, obviously. The backup was done carefully, and when I look up the receive address on a block explorer, the coins haven't moved. Is there a way I could verify that my receive address is linked to my mnemonic seed? Is it possible that my wallets, I've tried both Samurai and Mycelium, take multiple days to update to the right balance? Lots of questions packed in there. This is a common problem, and you've got to be careful when you're using seeds. It's often very useful to make a note of which wallet you use to initially create the seed and use the seed. There are 2 aspects to, or rather even 3 aspects to recovering a seed. First is the seed itself. Obviously, you need to have your 12 or 24 words, and you need to have them in the correct order, and they have a checksum. So you can know whether that's a correct mnemonic seed because your wallet won't accept it if it's not in the correct order or the checksum doesn't match. You've gotten this far. Obviously, you've been able to import the mnemonic seed into a wallet, so the seed is okay. Now, how does the wallet take that seed and generate receive addresses? Well, it uses two additional pieces of information. One is a potential passphrase, and you'll see from the comments of other people responding that that may be an issue. If you used a passphrase in addition to the mnemonic seed, which is a very common security mechanism, people do this in order to have a second factor when they're worried about the physical security of the seed itself, of the mnemonic, and they're not sure if they can keep the mnemonic secure. Your living situation, you might have roommates, you might have other people living with you that you don't trust. You might not have a physically secure location or a bank safe deposit box somewhere to store your seed with physical security. So maybe then you need a second factor. So if you have set a passphrase, then in order to restore your mnemonic, you also need to reapply that same passphrase. So every passphrase you use will generate a different set of receive addresses from the same mnemonic seed. So mnemonic seed plus passphrase A generates one address. Mnemonic seed plus passphrase B, different passphrase, generates another set of addresses. Mnemonic seed without passphrase generates a third set of addresses. So if you're not seeing the addresses generated that you expect to see, because there's no balance in them, for example, if you enter all of the information and you see no balance, then you may be entering the passphrase wrong. Now, keep in mind with BIP39 mnemonics, there's no such thing as a wrong passphrase. Every passphrase generates some address. The passphrase simply will generate an address that you've never used because you mistyped it or typed it differently from when you had before, and you're going to end up at a zero balance address. And of course, if you just take random passphrases or any random place, you're going to end up in a random address. It's not being used, and it's going to have a zero balance. So if you're seeing zero balance, one possibility is you're mistyping your passphrase, or you used the passphrase before and you're not using one now, which is the same as mistyping your passphrase. Finally, the third aspect of this is that a mnemonic seed is converted into addresses using what's known as a derivation path. And the derivation path looks like a string of numbers. For example, you might see something like M44 prime /0 prime /0 prime /0. That's a derivation path. And what that's telling the wallet is that in order to arrive at a specific address, you need to take from the master private key that is generated from the seed, and you need to derive the 44th hardened sub-address, and from that, the 0th or first hardened sub-address of that, and then the 0 hardened sub-address of that. Now, you don't need to worry about the details. The point is that if you use a different derivation path from the one you used in the beginning, you're going to end up at a different set of addresses that haven't been used and therefore will have a zero balance. How do you know which derivation path is used by your wallet? Well, there are standards, and 44 prime, for example, is a specific standard defined under BIP 44, which is a multi-currency, multi-account personal wallet. That's a specific purpose and derivation path that is common and standard across many, many wallets, the most likely one, in fact. But if you're deriving, for example, SegWit addresses, whether those are SegWit wrapped in P2SH, so an address that starts with 3, that's going to be derived from a different path than the traditional Bitcoin addresses that start with a 1. If you're deriving a pure native SegWit address, that's going to be derived from a different path from the traditional addresses that start with 1 or the P2SH wrapped addresses that start with 3. So for example, a native SegWit address, which starts with BC1, is going to have a different derivation path. The bottom line is, if you're arriving at addresses that have no balance, and the most likely thing here is that you're using a different derivation path than the one you used when you originally created the wallet, and the one you used when you originally moved money into these addresses. So you're looking at different addresses. How do you find the receive addresses? You try several different standard paths until you find them, or you try to remember which wallet you used and see what derivation path it used. Of course, the money hasn't gone anywhere. It's still there. And if your seed was transcribed accurately and you remember your passphrase, you're not going to lose anything. It's still there. You just have to figure out exactly where on this long and complicated derivation path it might be. Good luck with that. The one thing I will say is that you asked, is it possible that the wallets take multiple days to update to the right balance? With the wallets you described, which are Samurai and Mycelium, no, it doesn't take that long because they're not syncing a full chain in order to do that. They're using third-party servers in order to look up the balance of addresses and UTXO sets. So it doesn't take that long. It may take 10 minutes to rescan the wallet, but it should not take days. You should also see that within the settings, there's an option to rescan a wallet. Let's go back to the chat room and see how things are going. Apparently, I'm getting some good comments in the chat room. Someone says that the lightning is very good today, and beautiful new LED lights. And then somebody else says that now I'll need to get a better tan. Yeah, so what I'm thinking is what I'm gradually going to do is get blonde highlights on the tips of my hair, a spray tan that makes me look like a shriveled orange, and then I'm going to really over-whiten my teeth until I've got a dazzling Hollywood smile. And that's when you know that you should stop listening to anything I said, because the bleach has infiltrated my brain. Let's move on. I hope everyone's having fun on this beautiful Saturday morning. And we are getting some great questions here. By the way, I saw a lot of people responding to the Patreon announcement of my Q&A with comments in the Patreon announcement of the Q&A where they were asking questions. And if you're asking questions in the comments of the announcement post, you're not going to get an answer because that's the wrong place to ask questions. In order to get your questions answered, you have to ask them in the section where people can vote. Because I want to make sure that I'm answering the questions that the most people are interested in. If I start answering the questions that are in the comments, then you're bypassing the voting system, and that's not good. Hardware wallet security. Guy asks, is there a security risk to monitoring the balance of a hardware wallet with a watch-only wallet using the master public key? Similarly, is there a security benefit to splitting funds between a checking hardware wallet for more regular use and a savings hardware wallet that's rarely connected to a computer? Good questions here, Guy. There's no security risk per se to having a watch-only wallet using the master public key. In fact, you wouldn't be using the master public key. What you would be using is a hardened derivation XPub, which means that you would be using an XPub that derives to a specific account, perhaps M44 prime 0 prime 0 prime 0, which is the first receive address of the first account of the first currency in a multi-currency, multi-account derivation path. So because it's a hardened public key that's derived 3 levels down, and that's usually what your hardware wallet would export. If you ask it to export an XPub, that's what it's giving you. It's not giving you the root XPub. It's not insecure to use that on another computer, for example. However, there is a privacy risk. And the privacy risk is, of course, that anybody who has access to the computer that's watching these funds now knows, or someone who gains access to that computer may now know how much money you have on that seed. And they may change their opinion as to how much risk they're willing to take to compromise your security in order to steal those funds. So, if they thought you had $100 and they look at your XPub that's published and see that you have $100 million, now they're going to take a different set of risks to compromise that seed. So there is a privacy risk to that. However, you can decide how you want to do that. There's no technical security risk with simply exporting a master public key, which is appropriately hardened. Is there a security benefit to splitting funds between multiple hardware wallets or multiple seeds? To a certain degree, there is, and you've got to strike this really, really careful balance. So, for example, I do believe that there's good reason to have one seed that you use for cold storage that is not even installed on a hardware wallet, that you have only as a paper or other fixed medium backup, like stamped in steel or etched or something like that, with multiple copies that you do not install on a hardware wallet unless you absolutely need to. So that's a slightly higher level of security. And of course, you might have a passphrase to protect that too. And that's your really, really, really cold storage. And then you also have a device that you use for everyday operations. So for example, if you're running a business with crypto and you need to have an operating budget in order to be able to pay salaries or receive payments, et cetera, and you're pulling this hardware wallet out every single day to get another receive address for an invoice and pay a contractor and do things like that, then that would be more of a checking hardware wallet, if you like, or spending hardware wallet. And I do that, and I certainly believe there's good reason to do that. Now, how far do you take that, right? If one is good and two is better, is three best, is four best, how about 100? And then you get into other problems, because for every new seed you create, you need to have a very robust backup plan. You need to figure out where you're going to store this. You're going to need to audit and keep track of where the backup copies are. You're going to need to do some inheritance planning or some continuity planning for your business, et cetera, et cetera. The more you have, the more complex that gets. And there's no significant advantage to having more than two. Two is a good number, because then you have the one that's warmish and the one that's very cold. But creating other levels within there doesn't really make much sense. And there really is rarely need to take an amount that's, say, too large and split it across multiple seeds. Kevin asks, centralization on sidechains. Hi, Andreas, you've spoken at length about improved user experiences and scalability as a precursor to large-scale adoption. I've noticed many projects have begun using proof of authority and federated proof-of-stake sidechains to help solve these usability problems. Do you feel that some amount of centralization in sidechains and second-layer solutions is a useful interim step towards broader adoption? Or do you believe we can solve these problems without compromising our ideals of further decentralization? I believe we can solve problems without further compromising our ideals of decentralization. And I think these systems you're describing that use proof of authority or federated sidechains are not solving the same problems. They're solving different problems. They're solving problems that involve building a consortium of private companies in order to manage some kind of shared resources where they want to reduce the amount of kind of competition on standards and focus the competition on actual markets. So for that, proof of authority, federated proof of stake, I'm not a very strong believer in these systems. I think the area of applications that federated or more centralized consensus models have is rather limited. The idea that you're going to get a consortium of banks or a consortium of logistics and transportation companies that are tracking cocoa beans on the IBM Hyperledger system or whatever, that's going to be a powerful and viable application of blockchain, I'm skeptical. I think most of the interesting applications come from fully decentralized consensus models where there isn't the ability to collude among a small group of participants, and where you have strong guarantees of immutability that are backed by a proof of work consensus algorithm. But different people are exploring different solution areas. I want to make one point, though, that you say does some amount of centralization in sidechains and second-layer solutions is a useful interim step. Let's not confuse these two terms. Sidechains and second-layer solutions are very, very different. Sidechains use a different consensus model. You have to look at what is the security of the sidechain and how is the consensus model operating on that, because that security model is the model that is in use. So if you have two chains and they use two different consensus models, then your security depends on both of those consensus models. If one of them is weak, then your security is weak. Second-layer solutions don't have a separate consensus model. Second-layer solutions use the consensus model and the security model of the underlying layer. So if you take something like Lightning Network or Raiden or Plasma or something like that, these second-layer solutions use the consensus and security model of the underlying chain, Bitcoin, Litecoin, Ethereum, whatever. And therefore, they don't have this issue that you described with sidechains where there's some centralization of the consensus model. It's the same consensus model. So let's not confuse the two. They're very different approaches to solving the same problems. And I'm more interested in one set of solutions, especially second-layer solutions, than I am in another set of solutions, such as federated or proof of authority sidechains. Very, very different things. Let's check back into the chat room. I have to say, I am disappointed in the level of emojis currently being displayed in this chat room. I think we need to up our emoji game. The level of silliness is way too low. So please try a bit harder. Try a bit harder. Gareth asks about Bitcoin adoption outside of the first world economies. Hi, Andreas. I know from listening to your talks that you spend a lot of your time traveling to parts of the world that could really benefit from Bitcoin to address problems like a lack of access to banking or having an escape option from currencies with high inflation. In your experience talking to people in places like Argentina and listening to what they have to say, what are the key problems to adoption? And do you see progress being made to address these problems? For instance, is it a lack of fiat on-ramps? Is local Bitcoin still the only route into crypto for most people? Is it a lack of knowledge of Bitcoin, or a combination of all of these things and more? It's a combination of all of these things and more. A lot of it has to do with building basic infrastructure. So building wallets that are easy to use securely, and easy to use when fees are high, and easy to use when fees are low, and that use the different new technologies that exist in each blockchain to enable features that are powerful, whether that's replace by fee and child pays for parent type fee management techniques, or it's native SegWit addresses, or it's Lightning wallets and payment channels and things like that. It's infrastructure for exchanging, ATMs, as well as exchanges, but also local meetups, community building organizations, and opportunities to meet other people face to face. Local Bitcoins is great. It's not the only way you can meet people who are willing to buy and sell crypto, and there's a lot of ways to do over-the-counter transactions. It's about education and knowledge of Bitcoin, especially in other languages. So, one of the efforts I've been involved in is getting as much of the knowledge in this space translated into Spanish, for example, the subtitles to my videos. And these efforts are important because, it's not surprising, but a lot of the documentation, a lot of the articles, a lot of the applications are still only in English. And if you're trying to do work in developing economies, you need to address other languages, Spanish being the biggest one, of course, but then also French and other local languages. Okay, now the emoji game has much improved, much improved. Very good. Because that was disappointing, but everybody's picked up their game. Thank you so much. All right, glad you're having fun. Let's talk about full nodes. Professor Meow asks, Bitcoin full node versus Ethereum archival node. Does Ethereum need a sufficient amount of users to run an archival node? Recent crypto Twitter drama revealed that few entities are running a full archival node. Vitalik and other proponents claim that you can create the archival version using a full node. Is that true? When would you use an archival node versus a full node in Ethereum? In Bitcoin, would the full node be the equivalent of Ethereum's archival node? Why do Bitcoiners emphasize that a sufficient user number must run full nodes when Ethereum does not? Does it have something to do with different use cases? A lot of questions packed together, but all around the same theme. First of all, let's clarify terms. The term full node has changed meaning over the past 6-7 years and means a different thing. It means a different thing within Bitcoin. It also means a different thing between Bitcoin and Ethereum. Originally, a full node was a node that was not only doing full validation, but also keeping a full copy of the entire blockchain. Now, back in, I think, 2015, we had the first implementations of pruning. And pruning allows a node to maintain the most recent state of the blockchain and do full validation without keeping a historic record of, for example, spent UTXO and all of the transactions that have ever happened. So you can set your Bitcoin node to prune. And what does that mean? Is it no longer a full node? It just changes the meaning of the word full node. It's creating additional distinctions. So previously, we had a fully validating node, which effectively was also an archival node because it kept the whole copy of the entire blockchain. Or you had a lightweight node, which didn't do full validation and didn't have a full copy of the blockchain. Then the full nodes split into two. Essentially, you had full nodes that could do all the validation and are doing authoritative validation of transactions and blocks on their own and keeping the current state. So that's the kind of node that you could run at home, for example, to validate your own transactions and make sure that you've been paid. But you don't have to keep a whole copy of the blockchain anymore because transactions that have already been spent, outputs that have already been spent, are not relevant, and you can prune those and keep only a subset of the state. And that's done with the pruning command on Bitcoin Core. You can tell your system to say, prune your blockchain down to 50 gig, and it will keep, historical information for the last several weeks. But before that, it will only keep the aggregated state rather than all of the historical information. If you tell it not to prune and you keep a full copy of the blockchain, that's an archival node now. So we've changed the words for it. And archival nodes exist in Bitcoin, of course. I run unpruned or archival nodes. And that means I'm using up 250 gigs of disk space in order to have a fully indexed copy of the entire Bitcoin blockchain from Genesis block until today. Ethereum works differently. It works differently in that it has a much more complicated state tree, which takes up a lot more space. But it also has a lot of intermediate state that can be discarded without changing the validity constraints or validation constraints of a node. So running an archival node in Ethereum means keeping the execution state and receipts of every transaction for every contract that's ever been executed on Ethereum. And that takes a lot of space. last I looked, I think it was over 2 terabytes of disk space to do that. And also, it's very difficult to sync because in 2016 and 2017, there were a couple of denial of service attacks. And these denial of service attacks took advantage of vulnerabilities in the accounting for gas for certain types of operations that were either memory heavy and CPU intensive or disk intensive, or used up a lot of space on the blockchain. So there were 2 periods during which Ethereum was bombarded by either transactions that took a very long time to validate or transactions that created millions of empty accounts that had to be stored on the blockchain for no reason whatsoever, bloating the blockchain. There were 2 hard forks to erase this information and remove all of these wasted transactions, essentially stop the denial of service and change the accounting so it can't happen again. But if you start booting a node from 0 and you try to validate the Ethereum blockchain from scratch, when it reaches those periods in time in 2016 and 2017, your node will get bogged down. You're going to need a lot of CPU and a lot of disk space and a lot of memory just to be able to unpack, validate, and go over those transactions. So most nodes don't do that. They simply fast forward to a checkpoint after that point and ignore the detailed validation of all of those transactions. It's been done once. It doesn't need to be done again by your node in order to have a full copy. And that's one. The other one is that Ethereum is much more aggressive at pruning because its scalability constraints or its scalability characteristics are much worse than other blockchains because it has to keep all of the state of the contracts. So Ethereum uses more aggressive pruning, which means that very, very few, if any, nodes keep a full archival copy of the entire Ethereum blockchain since the Genesis block. That doesn't mean they can't validate. That doesn't mean they can't even validate all of the information correctly based on the latest state. It just means that if you ask them to go and look at a specific execution of a contract in the past that's already been validated and reconstruct that, they need to rebuild the blockchain again. And it's very difficult because you're not going to find any peers who are going to give you that data because there aren't that many, and they're not online all the time, and they don't have the bandwidth to bootstrap other nodes so easily. So it's difficult to do that in Ethereum. Different use cases, different scalability characteristics, different culture between Ethereum and Bitcoin. And as a result, you get these differences between archival nodes. Loic asks, 1 transaction blocks mined. I've noticed on a block explorer that some blocks are mined with only 1 transaction, the transaction that rewards the miner, the Coinbase transaction as it's known. Do you have an explanation for that? Why would miners not include any transactions in a block? The answer is really simple, Loic. It takes time for a miner's equipment to validate the previous block and determine which transactions were mined and which transactions need to be removed from the mempool. During that time, when a miner has not validated and cleaned up the mempool, they can't include any transaction safely because if they include a transaction that's already been included in the previous block or that conflicts with a transaction that's already been included in the block they just received, then they would be mining an invalid block, and they're going to lose all of their time. So during the time that they're still validating the previous block and removing all transactions that double spend or that have already been mined, they've got to mine something. The mining equipment doesn't stop. So what they do is they mine an empty block. So there's this brief period of time. Sometimes it may take up to 1, 2, even 3 minutes, during which a miner who has not received all of the transactions and has not validated all of the transactions from the previous block needs to mine something and will mine a block with only the Coinbase. As soon as they finish validating, now they can add transactions to the block and mine a block with transactions. Now, if during that period of 1 to 3 minutes, by coincidence, they find a proof of work solution, well, then they've got a valid block. They're going to publish it, even though it only has one transaction in it. That's fine. This doesn't remove security from the Bitcoin blockchain. Quite the opposite, in fact. Having an empty block mined increases the amount of work in the chain and secures the chain. So it doesn't matter if during that 1 or 2 minutes when they're validating, they mine an empty block. It doesn't remove from available capacity. It doesn't make it less likely you're going to find another block in the next 2 minutes, because those are independent probability events. It simply means that they added a bit of work to the chain, which makes it harder to attack. So it's all good. Empty blocks are security. Empty blocks give us proof of work, and that increased work on each chain means better security for the chain. And they don't reduce the capacity of the blockchain because they don't reduce the probability of you finding another block within the next few minutes. Ken asks, Hedera Hashgraph, is it a Bitcoin killer? Hedera Hashgraph and its coin HBAR sounds like the ideal coin. It has complete asynchrony, no leaders, no round robin, no proof of work, eventual consensus with probability of 1, and high speed in the absence of fall. It sounds like a Bitcoin killer. Bitcoin is based on proof of work. HBAR is not, and claims to provide the same or, if not better, use potential. I hear these claims, and if you've been in the space for 6 or 7 years like I have, then there's always a Bitcoin killer, a Bitcoin 2.0, a better implementation of Bitcoin just around the corner that someone has invented that solves all of the problems. The truth is that there are design and engineering trade-offs. And these design and engineering trade-offs, if you choose to do something a different way, then you end up with a different set of trade-offs between scalability, security, and decentralization. Now, you can pretend these trade-offs didn't happen. You can pretend that you maximized scalability, security, and decentralization. But effectively, most of the time, what we're talking about is a different trade-off, not no trade-off. Trade-offs are real. Engineering trade-offs happen. You can't just have the best of everything. You sacrifice something when you make a choice in order to maximize something else. These trade-offs are real. And honest engineers acknowledge these trade-offs and show what trade-offs they're making in a very deliberate way. Bitcoin is not designed to be the most scalable blockchain. It's designed to be the most decentralized, secure, and robust blockchain. There is a difference, and that requires some sacrifices in scalability, but not sacrifices for no reason, sacrifices for a very good reason in order to increase decentralization. When you hear other systems say, we can do Bitcoin better than Bitcoin, or we've solved all of the problems without any trade-offs, look at those claims very, very carefully. So there is a trade-off here. And the trade-off is in decentralization. Almost always the trade-off is a reduction in decentralization or a reduction in the degree of immutability of the chain. You see, the other thing that proof of work does that is not easily replaceable and often overlooked by people criticizing proof of work is proof of work provides immutability of the past, even under 100% collusion circumstances, meaning that even if 100% of the miners who are participating in proof of work decide to work together to change the past, to reverse a transaction that happened and make it like it never happened or something like that, they still have to expend the energy. Even not a 51% attack, even 100% consensus attack against Bitcoin does not change the requirement that you have to prove work and you have to expend energy to prove work. If you go back to change a transaction that happened 2 months ago, in a proof of work system, you have to remine all of the blocks from those 2 months. And you have to expend energy to do that, even if you control 100% of the hash rate. You can't change the consensus rules because you will end up mining an invalid blockchain that will be rejected by everybody else. In systems that don't use proof of work, that is not the same level as immutability. That level of immutability is not guaranteed. 100% of the participants in a federated consensus model, in a staking consensus model, etc., can go back and they can change the past without expending any energy. So it costs 0 to change the past. Therefore, collusion is possible. In proof-of-work systems, with 100% collusion, you still have to spend the energy, which means that it is not free to change the past. Changing the past has a cost, and that cost is independent of the amount of hash powers you have or the control over consensus you have. And so these are not equivalent things. You can't just say, well, we did away with proof of work and we don't need to use the energy. Great. So what did you put in its place, and how does it achieve the same things? It does not achieve the same things. Now, I don't study Hedera Hashgraph to the degree that I study other consensus models and other solutions. I understand blockchains. I kind of understand how a tangle works. And I understand how a hash graph works. But I think the claims that are being made as to solving all the scalability and decentralization problems of proof of work by doing away with proof of work don't stand up to serious scrutiny in that case. And there may be great applications for which a hash graph is better than a blockchain, for which a federated or proof-of-stake system is better than proof of work. Maybe there are solutions like that. Let them explore them. But in terms of the robust, decentralized, nation-state resistant sound money that Bitcoin does, with very high degree of immutability that's protected by energy, you can't just simply do away with that and solve that a different way. At least no one has. Let's see. Oh, now we have proof of emojis happening here. Very good. Everdread asks about crypto book recommendations. Hi, Andreas. In a recent interview, you spoke about your passion for reading. I've already read and loved your book, so what else do you recommend in the crypto, decentralization, and tech space? Any sci-fi books about a distant crypto future? Thanks, Everdread. Probably one of the most influential authors that I've read almost everything they've ever published, if not everything they've ever published, that has influenced my thinking a lot, is a cyberpunk author called Cory Doctorow. Cory Doctorow has written a number of amazing books. I'm a huge fan. And his latest book, Radicalized, just came out. I haven't started reading it yet, but I've loved every single one of his previous books, and they speak to this decentralized, autonomous, software-based, community-oriented, open-source future. Cory Doctorow is very strong in the areas of intellectual property and Creative Commons, for example, in defending general-purpose computing and open computing, and in fighting back against various forms of centralization and control. So if you like all of those ideas, that might be a good place to start. I certainly would recommend it. Satender asks about vanity addresses. In your book, Mastering Bitcoin, there's a section around vanity addresses and how there are pools that can generate such addresses for some fee. I'm surprised to not see any mention of how those private keys are secured, considering that they're generated for you by someone else? That's a great question, Satinder. So first of all, let's describe what vanity addresses are. You probably have seen that I have a vanity address. You can see it on my website. It's a Bitcoin address that says 1 Andreas. And so it's 1 ANDREAS, and then 30 other characters after that. How did that get generated? Well, the simple answer of how it got generated is each character in that sequence has a certain probability of showing up. So for example, if I wanted to create an address that started with 1A, simple example, well, there are 58 characters in the base 58 encoding of an address. So in order to find an address that starts with 1A, all of them start with 1, at least in that address format. So ignore the 1. The second character is A. So on average, if I just pick random private keys and calculate the address that corresponds to that private key, 1 out of every 58 private keys I create will have an address that starts with A, because there's a 1 in 58 chance out of the 58 characters that that letter might be or number might be, that it will be an A. Great. What about the N? Well, there's 1 out of 58 chances that the second letter is going to be an N. So 58 times 58 is the probability of me getting AN as the first 2 characters. So I have to generate 58 times 58 keys before I happen to find one whose address by coincidence starts with AN. For AND, 58 times 58 times 58. ANDR, 58 to the power of 4. ANDRE, power of 5. A6, S, 7. So I need to generate 58 to the 7th power, or 58 times itself 7 times, private keys before I happen to chance upon one on average that starts with 1 Andreas. And that's exactly what I did. Although I didn't do it, I used a pool. And why would you need a pool? Well, simply because the calculations you need to do to generate the Bitcoin private key, to then do an elliptic curve multiplication to find the public key, hash that twice, calculate the checksum by hashing again, and then producing a base 58 encoded address so you can see if that address matches by coincidence the pattern that you want. That takes a fair amount of computation. I can do it on my laptop with a GPU. But what if instead there were 100 computers with 4 GPUs each that were very powerful, and they could do that at a rate of billions and billions of keys per second? Well, I'd get to my 58 to the power of 7 much faster and do it much sooner if I had access to that many computers. And you can rent computers like that to do your calculation. So to Satinder's question, why is that secure? How is that secure if they generate the private key? Well, it has to do with a little trick of elliptic curve arithmetic that allows you to have the vanity pool generate private keys so as to produce a vanity address without knowing the full private key of that vanity address. And it relies on the simple fact that the sum of private keys produces a public key that is the sum of public keys. So if you take 2 private keys, A and B, and you produce the public key for A and the public key for B, then the sum of the 2 private keys, A plus B, and you take that private key, which is the sum, and you produce its public key is the sum of the 2 public keys of the 2 constituents, right? And that applies also to multiplication. So A times B produces a public key that is the factor of A and B. So the sum of private keys, the public key of this, let me try this again. Pause, deep breath. The public key of the sum of two private keys is the same as the sum of the two public keys derived from those private keys. And what that means is that when you use a vanity pool, you have a private key B, they have a private key A. You calculate the public key, let's call that capital B, for your private key B that they don't know. And you give them this public key, capital B. They then calculate capital A plus capital B, the sum of the two public keys, and see if that address is a good vanity address. If they find one that matches your vanity address, that produces one address, what they know is that the sum of the two public keys, A plus B, produces this vanity address, but they only know one of the two private keys. They only know lowercase a, which is the one they were calculating. So they can iterate very quickly on that one private key, and then calculate the vanity address of the sum of the two public keys. When they find a result, they send you their part, their private key, and they don't know how to produce the sum of the private keys because you have the other half. So you can take their private key and your private key and add them together, and now you have the private key for this vanity address. And they don't because they only had half of it. So that's how you work a vanity pool, or how vanity pools work, in a way that they can iterate through billions of private keys and produce a vanity address that you can use without them knowing the private key to that vanity address. I hope that was a good explanation. It's perhaps something that's easier to do with a whiteboard than it is just by speaking it. George asks about the space gain of Schnorr signatures. What is the percentage space gain that we should expect with Schnorr signatures? It actually depends on a number of different factors, because there's two places in which Schnorr signatures create space gains. The first one is the signature itself. Schnorr signatures are simply shorter than ECDSA signatures. So you automatically get, and I think it's somewhere between a 15 and 20% reduction in the space required to encode Schnorr signatures. Furthermore, most of the proposals for Schnorr signatures also include a change in the way the signature is encoded. Today, on the Bitcoin blockchain, signatures are encoded using a DER encoding, DER encoding, DER. And that's not space efficient, because it doesn't matter in most of the applications with digital signatures. Space falls into consideration. On a blockchain, it is. It's a very big consideration. So the DER encoding we use for ECDSA already has some room for improvement. And then Schnorr signatures are more compact. So those two efficiencies together, with an introduction of Schnorr signatures, we change the encoding, and the signature itself is shorter, 15 to 20% gain from there. But there's additional gains, because one of the things that you can do with Schnorr signatures is signature aggregation. So instead of, for example, having a signature on every input in your transaction, if you have a transaction that, say, has 2 or 3 inputs, now you need 3 signatures, 1 per input, and each of those signatures will take up 30-some bytes of signature space. With Schnorr, what you can do is you can produce one signature that is an aggregate signature for all 3 inputs. That's a 66% reduction in space, because you've now replaced 3 signatures by 1. And that signature can be computed by yourself if you have 3 inputs that all belong to you. But you can also do some forms of multi-party computation in order to produce an aggregate signature for inputs that are not owned by the same person. For example, in the case of a coin join or other multi-party transaction. Then there's a possibility of doing aggregation across transactions, which is an even more ambitious goal, and theoretically at least, You could do one aggregated signature for an entire block. That has its own complications, not easy to implement. That would be a huge space gain. So it depends how Schnorr signatures are applied. At minimum, 15% in space savings, probably close to 30, and with just transaction level aggregation, another 50 or 60% reduction in space because of Schnorr signatures. The follow-up question from George to that would be, would you vote, therefore, to lower the block size when you have the implementation of Schnorr? And I think not. I think that in fact, this gives us an opportunity to effectively increase the capacity of the blockchain without increasing the base block size. I don't want to go backwards in that, but that's a personal opinion, and it's not a very strong personal opinion. It's one that I would be open to persuasion. I don't currently buy the argument that the reason people are not running more full nodes is because of the bandwidth and disk costs of the current 1 megabyte base block size or 4 megabyte block weight that exists in Bitcoin's blockchain. So therefore, I don't think that's a huge problem today. And therefore, I don't think we need a radical solution like a reduction in the block size, which most people who propose this are talking about a temporary soft fork. Still, I don't really see the need for that, but I could be persuaded otherwise. Milan asks, the locking and unlocking Bitcoin script for Bitcoin Lightning. I have found great high-level descriptions of how the Bitcoin Lightning network functions. However, none where how it looks like on the Bitcoin script level. And so the question here is, how does the script inside the Lightning transaction look like? For unlocking, there are a number of different scenarios. The sender could close the channel and release the funds. The receiver could close the channel and release the funds. And the channel could get closed through some kind of uncooperative or timeout close. Let me see if I can very quickly find the specific bolt. So the answer you're looking for is straightforward. There is a specification for Lightning called Basics of Lightning Technology, or BOLT. BOLT is a specification of how the various parts of the interoperable Lightning network that is currently deployed works. And we're currently at the first version of BOLT. And there are a number of additional versions that are being worked on to progress this specification, BOLT 1.1, et cetera, et cetera. The BOLT standard consists of, I believe, 11 different sub-documents, BOLT 1, BOLT 2, BOLT 3, BOLT 4, and each one specifies a different part of the protocol. So some describe how the peer-to-peer network, how routing works, how invoices are formatted, how DNS is bootstrapped, how channel discovery happens, et cetera, et cetera. The one you're looking for is called BOLT 3. BOLT number 3 is the script format within the transactions. You can find this at github.com lightning network /lightning-rfc /BOLT 3. BOLT 3 is titled Bitcoin Transaction and Script Formats, which details the exact format of on-chain transactions which both sides need to agree on to ensure signatures are valid. And it has the scripts that are used inside the commitment transaction outputs for all of the cases that you're talking about, and how the closing transactions work. And that's where you'll find that script. Enjoy. It's some fun reading. You'll learn a lot about the scripting language. It's not easy to read. I can warn you about that, because it's been optimized to reduce the amount of data being used. Essentially, the script itself has been gradually refined and optimized and polished and compressed so that it does the thing we want to do, but not in a way that's very verbose so that it cuts down on the space that's used on the blockchain. So it's a bit difficult to read, but enjoy that. And with that, I think that's a great question to end this session on. Thank you so much for participating in today's Q&A. I hope you enjoyed it. Join me in 1 month for the April live stream Q&A. After today, I'll be resetting the question board so you can ask all of your questions, prepare some great questions for me to answer in just about 1 month. And again, thank you so much for all of the support that you've been offering, for helping me run this important educational mission and be able to support a staff of several people who help me get my message out further in more languages to more people around the world. I couldn't do it without your help. I hope to see many of you in upcoming happy hours and meetings and conferences and things like that. Stay in touch. Keep on Patreon. Watch my posts, and I will see you soon. Bye-bye, everyone.